Hi, we're doing speed, distance, time, and it's broken up into two sections. One is average speed, and one is upstream, downstream. What you see is an example out here. Okay, so this worksheet has the review with an example for upstream, downstream, and the average speed formulas. So we're going to discuss this entire thing. It'll take about an hour's time. Yeah. So let's begin with the upstream downstream section first here. It's fairly simple, the upstream downstream. Um, it may look complicated, like it's given elsewhere. Yeah. But with me, I'm going to make it easy for you. All right. So whenever they discuss, speed of boat, speed of barge, yeah, boat, barge, canoe, kayak. So these are all, things that, um, swim on the water. Yeah. Right. So don't get confused with these words, barge, canoe, and kayak. Okay. They're just like, tiny boats. Anyway, barge is a bigger boat. Canoe is smaller than a regular paddle boat. Yeah. Right. Kayak is probably what you use during river rafting, I believe, something like that. Yeah. Anyway, so let's say there was a basic question, right? So let's say the question is, let's go on to the first question. This one here. If a barge travels 40 kilometers upstream, 50 kilometers downstream, yeah, then find the speed of boat in kilometers per hour. Okay. So we'll if a barge travels 40 kilometers upstream and 50 kilometers downstream, find the speed of boat. So we'll ignore this question for the time being and understand, uh, the speed of boat. Yeah. Let's say it's X. Speed of stream, right? It could be a river, stream, pond, whatever, of kind of a rapid, whatever it is. So we say the speed of stream is Y, speed of boat is X. Okay. Yeah. So when we discuss speed of boat going downstream, right? All right. Imagine it's like you are on an escalator, yeah, going in the direction of the escalator. The only thing is that while you're on the escalator, you would normally not walk on it. You just stand still and let the escalator drive you forward, right? In the case of speed of boat going downstream, there are two things happening. The stream is like the escalator, which is moving at a constant rate of y, yeah. But at the same time, there's the speed of boat also, which is playing in the picture. All right. So the boat is not, you know, switched off. It is on and it is going at a particular speed. So there are two things happening. Yeah. One is the speed of the stream. Yeah. And the second thing is the speed of the boat. Therefore, the cumulative speed is x plus y, speed of boat going downstream. All right. So they will not use the word speed of, they'll simply say the boat going downstream is, 50 kilometers per hour. So in their example, it was 50 kilometers per hour. And the boat going upstream, right? It's like, again, think of the escalator. The only thing is the escalator is moving in one direction and you're walking in the opposite direction of the escalator. So every time you take a step, you're moving back. Every time you take a step, you're moving back because you're going in the opposite direction of the escalator. Something like this is happening in the upstream. The only difference is that you're not moving back. When you're going upstream, your boat is going upstream. You're not going back. Why? Because the speed of boat is greater than the speed of the stream. If the speed of the boat was lesser than the speed of the stream, then you'd never be going up. You'd never be going upstream. You'd be flowing with the river going down, flowing with the stream going down. Are you following? So the speed of the boat while it's going upstream has to be greater than the speed of the stream. Hence, the cumulative speed out here is gonna be x minus y because x is greater than y. Are you following? And that in the example is 40 kilometers per hour. And then the question is, what is x? So what is the speed of the boat? Right? So this is simply simultaneous equation. X plus y is equal to 50, x minus y is equal to 40, and then 2x is equal to, because these things cancel out, is equal to 90, and we got x is equal to 45 kmph. As simple as that. But what they do in other institutions and generally speaking, obviously, I'm not pinpointing any institution out here, but generally what they do is they hype it up, they complicate things, and they give ready-made formulas, right? So the formula that they say that the speed of a boat, yeah, and they use they kind of convolute things unnecessarily. They say speed of boat in still water, right? That still water is unnecessary, right? Still water is unnecessary. The speed of boat, simple. Speed of the boat when it is neither going downstream, neither going upstream. What is the speed of boat in general? But they'll have to complicate things by saying speed of the boat in still water. Still water meaning stationary water. So they unnecessarily complicate it because speed of the boat x in still water is the same as speed of the boat x. You know, it's the same thing. It's just going to say still water. So anyway, so the formula is the speed of the boat is simply x plus y by 2. And as you can see, 50 plus 40 is x plus y by 2 gave me 45. So that's the speed of boat. Now, if you simply mug this up, then it's not going to help. But this explanation definitely helps. Helps, not helping. If you mug it up, not helping, because when you mug it up, it's not making sense. You're not logically following it. Anyway, so that was the answer to the first question. Yeah. Let's move on to the second one. If a barge travels 50 kilometers per hour upstream and 70 kilometers per hour downstream, then find the speed of barge in still water. Now, see this barge in still water. I could have just said find the speed of the barge. In still water is just complicating things. So we'll do the same thing that we did right now. Yeah. It's the same question, same thing that we need to do. Yeah. All right. So let speed of boat be x. Let speed of stream be y. So when it's going downstream boat speed is equal to x plus y, and that is given as 70 kilometers per hour. And upstream boat speed is equal to x minus y, and that is given, I think, as 50 kilometers per hour. Okay, and that's about it. Now what we do is we have to find the speed of barge in still water. So x plus y is equal to 70, x minus y is equal to 50. Add them up, you got 2x is equal to 120, x is equal to 60 kilometers per hour, right? And and it is 50 and 70, and we have 60 as the answer. Easy, yeah. The first one was 45. Moving on to the third question. A boat has a speed of 40 kilometers per hour in still water. So again, I'm using the words in still water because that is what is generally, is the norm with most of the questions. So a boat has a speed of 40 kilometers per hour. Think of X in your head. Okay. Yeah. Find the speed of stream, that is Y in your head. If the boat can travel downstream 50 kilometers in 30 minutes. So these are very easy questions. So once you got your X and Y, it becomes very easy. So look at me solving it. Yeah. So you know that X is 40 kmph. Y is what we need to find. If the boat can travel downstream at 50 kilometers in 30 minutes, right? So 50 kilometers in 30 minutes, right, is 100 kilometers per hour, right? 100 kilometers per hour, 60 minutes will be 100. Double the time, the speed doubles. So X plus Y is equal to 100 is what we got. X is 40. So 40 plus Y is 100, correct? Yeah. So the speed of stream, therefore, speed of stream is 60 kilometers per hour. Now, in this situation, I've intentionally put it downstream and not spoken about the upstream because the upstream, the stream would carry the boat with it down. You know what I mean? So, right. So when I say that is because usually the speed of the boat should be greater than the speed of the stream. That is, X should be greater than Y, but X is 40, Y is 60. So imagine if you're going upstream with this particular boat with 40 kilometers per hour and stream is going down at 60, you're pretty much dragged down at 20 because the cumulative speed is probably 20 at that point of time, right? It's like you're walking against a strong gush of wind. Yeah. If you're walking against the strong gush of wind with a gush of wind is 60 and you are at 40 walking ahead at that speed, you're going to be dragged with the gush of wind. But the dragging would be at 20 if you're continuously going forward at 40. Anyway, so that was simple. That was the third question. Yeah. Moving on to the fourth one, kayak. So now I'm using different words, obviously intentionally, so that you understand that, don't get confused with what is a kayak. Is it something else? No, it's a boat. Okay. So kayak is paddled 50 kilometers downstream. So we know the speed of the kayak is, we don't know the speed of the kayak. We know that X plus Y is 50 kilometers downstream in 2 hours. So if it's 2 hours, if you less it, if you half it to 1 hour, then we get 25 kilometers per hour. So downstream, it is X plus Y is 25. So this is something that you got to do it mentally and pretty fast. All right. Yeah. So the speed of going downstream, if it's traveling 50 kilometers in 2 hours, then in 1 hour it'll be 25 kilometers. Therefore, X plus Y is 25. Then find the speed of stream. So we have to find Y. We have to find Y. Yeah. Assuming the kayak can be paddled at the rate of 10 kilometers per hour in still water. So we know the speed of the kayak in still water is 10 kmph, kilometers per hour. So that is 10. Y is what we need to find out. Therefore, Y is 15 kmph. Easy. Can't get easier. Okay. And finally, fifth question, if a canoe can be rowed at the rate of 20 kilometers per hour, yeah, downstream, right? So X is canoe speed. Canoe is another boat kind of a structure. So X plus Y is 20 and 5 kilometers per hour upstream. So X minus Y is 5. Then what is the speed of the stream in kilometers per hour? So Y is what we need to find out. Yeah. So that should add them up. We get 2X is equal to 25. X is equal to 12.5. So now remember, once we get 12.5, we need to substitute in any one of these. So I'm going to substitute in the first one. So X plus Y is 20. X is 12.5. Therefore, Y has to be 7.5, right? That's the answer. Okay, that's it. This is all about, yeah. So one thing that you would probably want to know is the shortcut, the formula that they use. So we know that x plus y by 2 is the speed of boat, yeah, and the speed of stream is x minus y by 2. As you can see, 20 minus 5 is 15, and 15 by 2 is 7.5. So that's the formula that they use. So these formulas, they're not helping. But if you want to mug it up, be my guest. All right. Right. So now we move on to the average speed concept. Okay. So so here I need to review it properly without the examples, in the sense that without solving the questions. Yeah. So let's go through the concept out here. So first of all, speed is distance upon time, right? Or distance is speed into time, or time is distance over speed. So these are all interchanged. Okay. All right. So that's the first formula. Second one is average speed is total distance upon total time. Okay. Remember these two main formulas. That's about it. Yeah. Okay. So now imagine city A to city B. Yeah. Where the distance between A and B is D, and you're going at the rate of 20 kilometers per hour. You're cycling, biking, driving, whatever you prefer. City B to city C, you're going at the rate of 30 kilometers per hour. Yeah, at the rate of 30 kilometers per hour, and the distance is D. The question is, what is the average speed, right? Okay, so see how I derive it. The answer will be 2xy upon x plus y, where xy are the speeds. But we'll derive it so that we understand logically what is happening. So average speed is total distance over total time. So total distance is 2d, because d plus d, the distance is the same. And time is distance over speed. So it will be d over 20 plus d over 30. Now the d's are there, which are common. So d's cancel out. So we got 2, 1 by 20 plus 1 by 30. Now, if I simply, use not the LCM, but kind of use it this way, 20 into 30. Instead of using 60, I'm using 20 into 30 directly, right? So 20 goes into 30, 20 goes into 20 into 30, yeah, 30 times, right? Like that. And 30 goes into 20 into 30, 20 times. So then what is the formula we finally get? We get twice 30 into 20, which is at the bottom. This bottom goes up upon 30 plus 20, which is nothing but twice xy upon x plus y. Did you get this step? Why I took 20 into 30? I could have taken 60 as the LCM, right? I could have taken 60 as the LCM. I could have taken 6 as the LCM and taken 20 out here. But I wanted to show you this formula, how it works. So remember, when the distances are the same and you have to find out the average speed, it is simply 2xy upon x plus y. Similarly, if you have city A, B, C, D. So out here, let's say the distances are the same and the speeds are 20, 30, 40. These are the speeds, right? Then what is the average speed? Is it Like in the previous case, it was 2xy upon x plus y. So in this situation, is it 3xy z upon x plus y plus z? Is it the case? No. Let's find out why. Okay. So we'll calculate average speed is total distance over total time. All right. So remember out here we are considering A to B, B to C, C to D. Distances are the same. Three different speeds. Okay. So total distance is 3D upon total time. Time one is, remember, speed is distance upon time. Time is distance upon speed. So D upon 20, D upon 30, D upon 40. These are the times, right? Time one, time two, time three, right? Total time. So now what we have is D's cancel out. So we got 3, yeah, upon 1 by 20 plus 1 by 30 plus 1 by 40. Again, if we simply take the LCM, no, we don't take the LCM, right? We'll take 30, 20, 30, 40. So now 20 will go into this 30 into 40 times, right? Plus 30 will go into 20 into 40 times. Plus 40 will go into 20 into 30 times. So therefore, what we end up getting is 3x into y into z, which is what we got on the top. But the bottom is not xy, x plus y plus z. It is xy plus yz plus xz. Are you with me, guys? So this is the formula for the average speed for A to B to C to D. Okay. So do not generalize it just because it's 3x, y, z, x plus y plus z. Yeah. Always logically derive it. Right. And now the second concept. Yeah. Second concept is that suppose A to B, B to C, right? You're traveling at the rate of 20 and at the rate of 30, but the time is same. Time is same. Time is same, right? Time is same. Then find the average speed. So average speed is total distance upon total time, right? So total distance is what? Speed into time. Distance is what? Speed into time. So there'll be d1, d2 upon t plus t because time is the same, t plus t. So what is distance 1? Yeah, it is speed into time. So 20t. What is distance 2? Speed into time. Speed is distance upon time. So distance is speed into time. So 30t upon 2t. So therefore tt cancels. It will be 20 plus 30 upon 2. So what is the generalized answer for this? Average speed is simply the average of the speeds when time is same. When time is same. And can you generalize it for, if it is A to B to C to D? Yeah. Yes. Now you can generalize it. If it's A to B to C to D, then it will be x plus y plus z upon 3, where x, y, z are speeds. Are you with me, guys? Yeah. So this time it can be generalized because it just derives that x plus y plus z by 3. Okay. Yeah. Let's solve the questions. Let's begin with the first one. If an aircraft flies at a speed of 1200 miles per hour, what is the distance covered by it in 12 seconds? So this is fairly simple. 1200 miles in 1 hour. And what is 1 hour? 3600 seconds. So in 12 seconds, what is the distance covered by it? Very simple. So it's simply, unitary method. Less seconds, less distance covered, right? Less time, less distance covered. So 12 into 1200 upon 3600. So 20 goes with 20. 12 goes into this 3 times and 3 goes into this 4 times. So 4 miles is the answer. Got it? Yeah? Okay. Second question. Arun travels by car from A to B, yeah, at an average speed of 90 kilometers per hour, and city B to city C at an average speed of 60 kilometers per hour, right? So the question is, if the distance between city A to city B and between city B to city C is the same, yeah, find the average speed for the entire journey, right? So we can now apply the formula 2xy upon x plus y. So that is 260 into 90 upon 60 plus 90, which is 2 into 60 into 90 upon 150. So 10 goes with 10, 15 goes into this 4 times, right? And then we got 9 4 the 36, 36 to the 72, 72 kilometers per hour, right? Yeah. Third one. Jenny bikes from point to point Q at an average speed of 7 kilometers per hour, and from point Q to point R at an average speed of 12 kilometers per hour. Yeah. If a travel time for both the journeys is the same, so T is the same. Yeah. Find her average speed for the entire journey in kilometers per hour. So average speed when the time is same is x plus y by 2. So it's simply 7 plus 12 by 2, which is 19 by 2, which is 9.5 kmph. Right? That's the answer. Right. Now it might get complicated. Fourth one. So Max drives to work at a distance of x miles. Okay, right? X miles at an average speed of p miles per hour. P miles per hour, right? And then returns home. So x miles is home to work. W work, H home. That is home to work x miles. All right. And returns home using the same route at an average speed of q miles per hour. So going to work, to work, and back home. Back home at q miles per hour. Back home. If the total time taken for the entire journey to work and back home is 8 hours, right? So total time to and from work, to work and from work is equal to 8 hours. Then which of the following is the distance covered by him on his way back home in miles? So this answer should be equal to x, correct? Because the distance from home to work is x miles. So the question is then which of the following is the distance covered by him on his way back home in miles? So it's x miles. But do we have x as an option? No, it's all p, q, and h. So we need to figure out how to solve this. So what information we have? We have x miles, we have q, p miles per hour, q miles per hour, and we got h hours. All right. So we simply apply the fact that distance is same, right? So therefore, average speed is what? Total distance over total time, right? In case of when the distance is same, it is 2xy upon x plus y, which in this case is 2pq upon p plus q. And that is nothing but total distance, 2x upon total time h. Are you with me? And what we need to find out, we need to find out the distance x, right? So we got our x, 2 and 2 cancels. Therefore, p, q, h will go there upon p plus q is equal to x. And x is what we need to find out. So that is C is the answer. Easy, right? What is the distance covered by him on his way back home in miles? On his way back home, they're not asking what is the total distance. They're just simply asking on his way back home. So that is x. Okay. All right. So this is a complicated question. I made it easy without, discussing more on it. You have to pause the video, understand the question, and then understand my solution. Okay. Fifth question. Rita rides on a farm every day covering a distance of 10 kilometers on horseback. So we know every day 10 kilometers is what she's riding on a horse. If she rode on Monday at a speed of 20 kilometers per hour, on Tuesday at the rate of 15 kilometers per hour, that is riding on a horse, then what should be her average speed in kilometers per hour from Monday to Saturday? Monday to Saturday. Monday to Saturday. Considering that her average speed for the remaining days was 12 kilometers per hour. So remaining days is Wednesday. Yeah, average speed is 12 kilometers per hour, right? Thursday, Friday, Saturday, right? So individually we don't know, but average is 12 kilometers per hour. All right. So I'll directly go to the solution first to make it right. And then I'll explain you the kind of incorrect solution that you could be going for. So the first solution is average speed is what they're asking. What should be average speed in kilometers per hour from Monday to Saturday? We know the average speed for the remaining 4 days is 12, correct? So average speed is total distance over total time. So total distance is what? 6 days, right? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So 60 kilometers. Because every day she goes 10 kilometers. And time 1, time 2, time 3, right, is simply 10 over 20, right? Time is distance over speed. Remember, time is distance over speed. Plus 10 over 15, right? Plus what will this be? So remember, it is what? Average speed is 12 kilometers. So it'll be 10 by 12, 10 by 12, 10 by 12, and 10 by 12. So that will be 40 over 12. Understood? Yeah. Plus, 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 plus. So 40 over 12. That's how you need to solve it. Therefore, the average speed is, I can cancel out this 0 with the remaining zeros out here. Yeah. So I get 6 upon 1 by 20 plus 1 by 15 plus 4 by 12. Therefore, what I get is 6 upon, I'll take the average of LCM of 20, 15, 12 as 60, because 60 is a multiple of all three of them. So 20 goes into 63 times, 15 goes into 64 times, and 12 goes into 65 times. So will I write 5? No, it will be 5 into 4. So that is what you get. And then I'll continue out here. Yeah. Therefore, it will be 6 into 60 upon 27, right? 24 plus 3. So we got 3 320s are, 3 9s are, 3 2s are, 3 3s are. Therefore, we got 42 into 20, 40 over 3 miles per hour or kilometers per hour. Kilometers per hour as the answer. C is the answer. Now the question is, the error that you could have made is by taking 10 over 12 out here instead of 40 over 12, right? You'd assume that because the average speed is 12 kilometers per hour for the remaining days, I might as well as take, 30. And other mistake you could have done is 30. So that's the incorrect solution you would have got. You would have taken total distance as 30, and the total time you would have taken is 10 by 20, 10 by 15, 10 by 12. So if you do that, you'll get an incorrect answer. Got it? Yeah. Okay. And always remember that the average speed will be between 12 and 20. It will not be greater than 20. It will not be lesser than 12. That's another thing, because the speeds given to us are 20, 15, and the average is 12. So the average of the entire thing, yeah, all the 6 days will always lie between 12 and 20. It will not be lesser than 12. It won't be greater than 20. Okay. So the question is, can it be 20? Can it be 12? Yes, it depends on the speeds given to us. But usually and always it will not be over 20 or below 12 if these are the numbers given to us. If these are the numbers given to us. Okay. Yeah. All right. Sixth question. Okay, so now we are moving on to the last two concepts of speed. So this is not average speed. This is the speed like the downstream upstream case, but slightly different. Okay, so let's understand this. I'll review this quickly. Okay, so remember, if you have A driving in one direction and B is driving in the same direction behind A, all right, right, and this is, let's say, 20 kilometers per hour, and this is, let's say, 10 kilometers per hour. All right. And let's say the distance between them is 40 kilometers. Right. So the one behind B is traveling in the same direction as A. And if you were to find out time, find time taken by B to overtake A, overtake A, or B, or catch up with A. All right. So we always take the difference of the speeds. So the time taken is difference of distance between them. Distance, time is distance over speed, right? So distance between them upon the difference of the speeds. So that is 40 over 10, and so the time is 4 hours. Got it? And we'll solve it using equation. So distance covered by B is clearly distance covered by A plus 40. And that's how we can use the equation and solve it. Now, one crucial assumption that you have to make is that, let's just say that we find them at 12 o'clock in the afternoon. 40 kilometers is the distance between them, right? And we find A at 12 p.m. and we find B at 12 p.m., 40 kilometers behind A. And from 12 p.m., yeah, at 4 p.m., B catches up with A. So from 12 to 4, A also traveled for 4 hours and B also traveled for 4 hours, right? We don't care that before 12 p.m., A could have started the previous night 12 a.m., right? Or probably it would have started at midnight at 12 a.m., correct? We don't care about that. We don't care if B had just started 1 hour back. But at 12 p.m., we found them 40 kilometers apart. And at 4 p.m., we found B caught up with A or B overtook A. So from 12 to 4, right when we are trying to find out how much time will B take to overtake A or how much time B will take to catch up with A, we don't care about what happened before. We are talking about what happened from 12 to 4. So 12 to 4, if you realize the time taken by A is also 4 hours, time taken by B is also 4 hours. All right. So I'm explaining you in a sense that we have already got the solution. I'm explaining it to you using the equation. But in the equation, had we not solved this part, so in the equation, distance covered by B is speed into time. And I'm trying to explain you that the time t is constant or time t is same for B also and for A also. That's what I was trying to explain you. That the time from 12 to 4, like this 4 hours, is the time taken by both of them to travel. It wasn't that A was just standing there waiting for B to come. No, nah. No, nah, because A is also going at a constant rate. Correct. So distance by B is 20t, distance covered by A is 10t, speed into time of A plus 40. Why plus 40? Because in order for B to catch up with A, B will have to cover that 40 kilometers, and hence we get this formula, which is nothing but this one. If you see 20t minus 10t is 10t. Yeah, therefore 10t is equal to 40, right? Subtraction. And therefore t is equal to 40 over 10. And what is 40? Distance between them. What is 10? Difference of the speeds. And the next concept is, imagine from one point A is going in the opposite direction of B. So opposite direction is not only going away from each other, but also going towards each other. Also going towards each other, right? So this is going, let's say, at the rate of 20, and let's say this is going at the rate of 10 kilometers per hour, right? So let's say question is, after how much, after how long will they be will they be uh 300 kilometers apart? After how long will they be 300 kilometers apart? So the formula is time is distance between them, and this time remember it will be sum of the speeds. So distance between them 300 and sum of the speeds is 30. So therefore I got 10 hours. After 10 hours they'll be 300 kilometers apart. Are you with me? So remember, when they're traveling in the same direction, we take the difference of the speeds. When they're traveling in opposite or toward each other, yeah, it will be sum of the speeds. So again, if we use this equation, distance covered by B, so you have to use common sense. We can't always use that B is equal to dA plus the distance. Distance B plus distance A is 300. And again, imagine they started at 12 p.m. and 12 p.m. 10 hours A went and 10 hours B went in the other direction. So we found them to be, covering 100 kilometers for A and 200 kilometers for B, and that's how we found 300. But we are trying to find out using the equation. So again, the question is, at 12 p.m. they started. So clearly at 10 p.m., after 10 hours, they were 300 kilometers apart. So again, if you see, the time taken is the same. All right. So 20t plus 10t, out here t is the important part, is 300. Therefore 30t is 300, and therefore we got t is equal to 300 by 30, which is distance between them upon the sum of the speeds. And we got 10 as the answer. Got it? 10 hours. That's it. So that was the review, and now we'll solve questions based on it. So question number 6. Right. What do we have? We have a train A travels away from train B at an average speed of 80 kilometers per hour, and train B travels away from train A at an average speed of 90 kilometers per hour. Then in 8 hours after train B departed, how far were the two trains apart if train B began an hour after train A departed from the same junction as train A? So it's a very wordy question. I intentionally did that to, confuse you. So one part we know that train A travels away from train B at an average speed of 80 kilometers per hour, right? So that is A at the rate of 80 kilometers per hour. And train B travels away from train A, yeah, at the rate of 90 kilometers per hour. Okay. Then in 8 hours after train B departed, then in 8 hours, so time taken is 8 hours. After train B departed, all right. So we talk about in 8 hours after train B departed, how far were the two trains apart if train B began an hour after train A? So remember, train B began an hour after train A departed from the same junction as train A. So this is the same junction. But what is happening? B departed an hour after train A. So out here, A has already traveled 80 kilometers in 1 hour. So A is already 80 kilometers away and B has not yet started. Now, in 8 hours after train B departed, then in 8 hours after train B departed, so we first find out in 8 hours what is the distance covered by B? 90 into 8. Distance is speed into time. So 720 kilometers traveled by B in 8 hours, and for A it will be 80 into 8, 640 kilometers in 8 hours. That is in 8 hours, okay? But remember, A has also traveled extra hour. How? Because then in 8 hours after train B departed, and train B departed when? An hour after train A departed. So that extra hour distance covered by A is 80 kilometers, correct? And hence, how far are they apart 8 hours after? So that'll be 0, 14, 14. So 1440 kilometers. So if you mess up with the wordings, you will go wrong with this question. Okay, last question, seventh one. At 2 p.m., Richard found that his wife Nina drove away with his favorite car at 11 a.m. in the morning of the same day. So 2 p.m. Richard found that his wife left at 11 a.m. in the morning of the same day at an average speed of 60 kilometers per hour. Right? Right? So Nina, and that is Richard, 11 a.m. to 2 p.m., what is the difference in the time? Or what is the so what is the time that has passed by the time Richard came to know? 3 hours, right? 11 to 12 1, and 12 to 2 2 hours, so 3 hours. And so in 3 hours, Nina traveling at 60, she is already 180 kilometers ahead of Richard. Yeah. So by what time will Richard catch up with Nina if he drove Nina's truck at an average speed of 90 kilometers per hour? And so this is a case of both traveling in the same direction. So it is also mentioned out here. In the same direction as Nina, assuming they both traveled without any halt. So very simple question. They're both traveling in the same direction. You can either use distance covered by Richard is equal to distance covered by Nina plus the 180 kilometers, or you can directly use the formula, which is time is equal to distance between them upon the difference of the speeds. That is 6 hours. So the question is, at what time, by what time will Richard catch up? So this 6 hours, do you add to 11 or do you add to 2 p.m.? Obviously to 2 p.m. because Richard came to know at 2 p.m. Na? So 2 plus 2 p.m. plus 6 hours is 8 p.m. So 8 p.m. is they catch up. So I intentionally gave the time so you realize that don't add to 11, add to 2. So that part you need to understand. This is a very simple worded seventh question, but they can complicate it. And then you will not figure out whether to add 6 to 2 p.m. or 6 to 11 a.m. And if you're solving it this way, then distance is speed into time. So again, remember from 2 p.m., Nina has already been traveling since 11 a.m. But at 2 p.m., yeah, Nina, we'll have to look at the situation that 180 kilometers apart at 2 p.m., Nina is 180 kilometers away from Richard. So from 2 p.m. to 8 p.m., those 6 hours, Nina has also been traveling and Richard has also been traveling. So therefore, the time taken is the same, and this time the time taken, yeah, is T, right? We are ignoring the fact that 11 a.m. Nina started, but starting from 2 p.m. to 8 p.m., they both were traveling for 6 hours. So 6 hours is the answer, but we are finding out using this equation plus 180. And so it is 30t is equal to 180, and therefore t is equal to 180 by 30. Yeah, whatever. So it is 6 hours, right? Yeah. So I'm having trouble writing. It's because of the whatever the app that I'm using has trouble. Anyway, so that's it, guys. We are done with the speed, distance, time concept. I've tried to cover all the important concepts. There are many more, obviously, but this is more than enough for any of the aptitude tests. Right there. That's it. Thank you very much for your time. And remember, all the videos for the UGC NET are under the YouTube channel Friendly Spider playlist UGC. So just look for the word UGC in the playlist, and under them you'll have several videos on the math content, the part A of the NET exam. Thank you.